With the base catalyzed transesterification process, it does what the acid catalyzed one does. We have an ester and we turn it into another ester using an alcohol. Alright, so let's look at how this might be expressed. There's actually two possible ways you could see this reaction. We could see it like this, with the O negative and in the solution of just OH. And as I said earlier, whenever you've got a negatively charged species like this, it's normally in a solution of its conjugate acid. And remember, to make a conjugate acid, you just have to add H plus to whatever you're talking about. So the conjugate acid of this would be its alcohol, which I've got down here. It does follow the same patterns as we've been discussing. You can see that the Y group is going to be this one here, and the X group will be this here without the negative charge on it. X negative will have the negative charge, so there's your X group over here connected onto the C double bond O, and here would be the Y negative as we would have predicted. So this is still following the same pattern. Now the other variation on this one is that in the second step we can add H plus, and that would protonate the alcohol as well. I'll show you both. Let's take a look at the first one. So in the first step you can see that the O negative will come in and attack, and we know that if we've got a choice between two things, it'll always be the charged species that will attack, not the uncharged one. Alright, so now we've got this with the O negative, and the negative comes down, kicks out the leaving group. Gives us our ester product as well as O minus on the leaving group, which is over here. So the other possibility we have is for the H plus in the second step, pretty similar process. Attacks the C double bond O, electrons jump up on the oxygen. Negative comes down, reforms the C double bond O, kicks out the leaving group as O negative, and then we get our products here. And then, now that everything's over with, we can go ahead and add the H plus in the second step, which gives us our neutral alcohol as a product. Alright, so this is different from the hydrolysis, because in the hydrolysis, at this step we actually formed a carboxylic acid, and that carboxylic acid was in a basic solution, so we had to remove a proton. That doesn't happen here. The only thing that happens is that we get an ester, and the esters aren't subject to deprotonations like the alcohols are, so we're not going to have that complication occur. But all I would want to say is that there's two possibilities of seeing this, two variations, and one has the H plus as a second step and the other one doesn't. But you can see how we have the H plus, it just all it does is just protonate the O negative that we get from the leaving group.